Okay, for questions like this, right, whereby we have the start state undergoing a few decay turn into a end state nuclide, and you're supposed to deduce the decays that have taken place, right? You must first understand quite clearly, right, what's the effects of the individual type of decay. So let's look at alpha decay first. Whenever you have a alpha decay, right, let's call a substance, right, let's call it W, okay? You have a A and a Z. So this will cause, right, alpha decay will cause both the mass number and the charge number, which is also the atomic number, to change. So once the atomic number change, right, the symbol will change, okay? So the W will turn into something else, maybe call it X, okay? And you'll have, right, maybe not X, but maybe P, not to confuse the X in the question. So here, right, will be A minus 4 and Z minus 2 plus 42He. Okay. Beta decay, let's need to look at two types. Beta plus first. So beta plus, right, you will have, let's say AZW, once again, turn into what? So beta plus, right, turns a proton into a neutron. Okay. So you will have, right, the neutron number is still the same, but the proton turns into the neutron. So here, right, the number of protons will have changed. So Z minus 1, okay, turns into a certain P plus a 0, 1 E. So this is the positron, which is the beta particle, plus the neutrino. Beta minus similar, but is opposite of beta plus. It is a neutron turned into a proton. Therefore, right, the top number is still the same, but bottom number, right, you have plus 1, okay, and turn into Q. So here is 0 minus 1 E plus a neutrino as well. Finally, right, gamma decay. Gamma decay, right, you will have no change in this entire thing. It will be the same nucleus, same nuclide, okay. It's just, right, an excited version of the nuclide turning into a ground state of the nuclide, okay. So doesn't change either number, okay. So when we look at this pathway, right, we see that we look at the top pathway first. We see the top number turn from 218 to 214. So there must be a alpha decay happening somewhere, okay. And then you see, right, the second process in the top chain is a beta minus decay. Beta minus won't change the mass number. Therefore, right, the first one must be a alpha decay, okay. Then vice versa, right, the bottom chain must also have a alpha decay and a beta decay. And it must be a beta minus decay. I mean, the options here don't have a beta plus, but we know that it has to be a beta minus. It cannot be a beta plus, because, right, undergoing an alpha decay plus a beta decay, beta minus decay, right, will have, let's just write it out, okay, here. So let's just call this number Z, okay, this number Z. So here, right, will have been 214 and Z minus 2. Undergo beta decay, right, what happens to the charge number? It will be 214 Z minus 1. From minus 2 add 1. So therefore, right, the bottom chain must have been beta minus decay first. So you turn into 218 Z plus 1. Then after that, right, you subtract 4 from the top, 2 from the bottom for the alpha decay. So you get 214 Z minus 1. Okay. So that will be option A, option B, sorry.